Yeah, good morning, everybody. And this is Dr. Mansour with the Professional Engineering Services and Education. And this is a free workshop, or you call it the question of the week, whatever name. I'm supposed to be here with you from 7 to 8:30, but unfortunately, I have to leave in about 20 minutes. I have an urgent medical stuff. I have to take care of it for one of my family member. 7:30, we do have an appointment this morning, so I have to leave in about 20 minutes or so. So forgive me for that. The same sessions, okay, or the same ID can be used for the rest of the sessions. So today is 8:24. I have many sessions. In fact, I have 8:31, 9:14. All these dates are given on our website. So I have many sessions. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 sessions left. 10 sessions. I don't know when is your exam, but do your best. And I will do my best. I will make also the recording available. Three problems I can discuss it very early this morning in this very short time, and I will continue next time when we meet. The first problem, or the first question that I received, they're called the question of the week, and probably we are going to post this on our website. So today is the 24th of August, 24, and this is a transportation PE7 CBT. And since I call it the question of the week, or the free workshop for the questions, okay, you are very welcome to send me any question you think about it, or you are interested to know more, or you from my materials or from other materials, and I will be glad to go over. So three questions. Number one, one question is related to the peak hour factor, okay, and the second question is related to coordinates of horizontal curves, and the third problem is related to the super elevation. All these things I covered in my classes, and also they are available in my books, but it's just the question could be asked a little bit different, or maybe the way that the question that are asked a little bit, I don't like to say tricky, but it is a little bit more involve a lot of computations, or maybe a conceptual question like the peak hour factor. All of us, we know the peak hour factor is given by the HCM. It is a famous equation, and the peak hour factors say that the V60 over 4 times V15. So this is the equation, the peak hour factor, which is a factor that adopted by the highway capacity manual, and we use it for the LOS calculations, level of surface calculations, as all of you know, and the peak hour factor is part of the equations that developed. So the peak hour factor, it should be calculated within 1 hour, and the 1 hour is defined as 4 consecutive 15 minutes. And they give you the volumes, okay, for example, from 6 o'clock maybe to 6:15, we have 1,000 vehicle. From 6:15 to 6:30, we have 1,200, and from 6:30 to 6:45, okay, 800, and from 6:45 to 7, okay, another 1,000. Let's assume that these numbers. So the traffic volumes in increment of 15 minutes are given. So the calculations here very simple. If I add all this, 1,000, so this is 2,200, 3,000, so this is 4,000. So the peak hour factor is going to be 4,000 divided by 4 times the highest number, which is the highest V15, or kind of V15 max. Okay, so in this case, the 1200 is the one governing. Okay, so in this case, it is 4000 divided by 4800, and this number is going to be coming, okay, less than 1 for sure. So this is easy calculation, and we did it many times, and I'm sure that you did it many times, and this, it came about 0.83, and this will be the value of the peak hour factor that will be plugged into the equation to calculate the LOS, or the flow rate, and so on. Not necessarily the question could be asked like this, or as we discussed in the class, he gave you from 6, and instead of 6 to 7, he can give it from 6 to 8. So I give you 2 hours, okay, traffic volume. So you have to define which one is the peak hour. And I solve a problem, you have to go and see it is from 6 to 7, or from 6:15 to 7:15, or from 6:30 to 7:30, or from, okay, 7 to 8, and so on. So you have to determine what is the peak hour first, and after that, calculate the peak hour factor. Okay, and somebody sent me something that a solution from somewhere, and he said that probably this is your solution. I don't recall this solution at all. Anyhow, so you have to determine the peak hour first. Okay, okay. So you pick the peak hour factor. Yeah, it must be within the peak hour, and we talked about that. The question could be a little bit different. Instead of asking to calculate the peak hour factor, either 1 hour volumes or 2 hours volume, and he can ask you which of the following is true about the peak hour factor, and he give you 4 answers, A, B, okay, C, D. Okay, what is the maximum value of the peak hour factor? Well, this is one of the answers. The maximum value, or the highest value of the peak hour factor, is 1. Can the peak hour factor to be 1? Okay, theoretically speaking, yes. Okay, so the peak hour factor, okay, the peak hour factor, it is less than or equal 1, and a greater than or equal. What is the minimum value? What is the minimum value for the peak hour factor? If the maximum is 1, the maximum is 1 if the volume, if it's assume 1000, 1000, 1000, 1000, so we'll give you 4000. So 4 times 4000, but since the increments are the same, so 4 times 1000, 4000, 4000 over 4000 will give you 1. So this is the theoretical if the flow within the 15-minute increment, okay, if they are equal. So the peak hour factor, theoretically speaking, yes, it could be 1. It could happen, very rare, but it is theoretically speaking, yes. What about the minimum value? Can the peak hour factor to be less than 0.5? And if yes, what is the minimum value? So the peak hour factor maximum is 1, and the peak hour factor minimum is 0.25. How this happened? Let's assume for the sake of discussion, I have here from 6 to 6:15, I have only 1000, and there is no flow in the other 3 and the other 15-minute increment. So only I have the flow, so it is 1000. So 1000 over 4 times, okay, so it is 1000 divided by 4 times 1000 will give you 0.25. So these are the limits. But if you look to my book, for example, you will find that we have some reasonable values. Obviously, these are the theoretical values, but we need to know that. We need to know the peak hour factor, okay? And the equations are there, and we talked about that. And also the reasonable values also for the peak hour factors are given in my book. You can look at it. Let me show it to you in 22 seconds. Here it is. Obviously, you can take my book with you, but or any other book. So the peak hour factor, here it is the hourly volume over 4 times, okay, the V15. Okay, here it is V hour over, and this is the HCM equation 4.2, as all of you know, HCM. Okay, chapter 4. equation 4-1 and the given in page here. And if you flip the page, you will find I talk a little bit about the peak hour factor and typical values. Okay, 0.8 to 0.95, and I remember I talked about the 1 and 0.25. Okay, and it is higher values for urban and congested facilities. He might ask you that which one is which one of the following is true. He can give you, okay, the peak hour factor has higher values in urban and congested facilities. It has a lower values in rural and in congested facilities. Yes, we need to know these facts. So not necessarily the question will be related, okay, directly to the calculations or computations, because conceptual questions are very, very important, and I need you to be aware of that. So this is something I need you to be aware of, the type of questions. As I said, that you are very welcome to send me the questions. Handwritten is sufficient, and I will do all, okay, my best. That's correct. Okay. There is an audio, yes, you can hear me. There is audio and video. One of you is asking, is there an, this is the first session, the answer is yes. And the second question you ask, if there is an audio, can you hear me? I believe all of you can hear me. And I can tell from my end here that the audio is working. So the video and the audio are working. Anybody has a problem with the audio? As one of you indicating that, to the best of my knowledge, the audio and the video, I am not put it on the mute, I think. Okay, now I can, yes, that's correct, yes, it is. If there's any technical difficulty, please let me know. So this is the first problem related, and also I will scan the notes, I will send it to you. The second one, coordinates. During the class, I covered coordinates, and the coordinates are challenging problems during the PE exam. And there is a famous problem, we talked about it before, and I send you my solution. I'll be glad to include it, okay, in one of the many exams, where you have a horizontal circular curve, and it gives you the information, the coordinates of the beginning of the curve, and maybe the coordinates of the PI, and he gave you some information, ask you the coordinate of a certain, for example, a point where a power line is crossing, and we'll solve this problem. Coordinates problems are really challenging problems, and it takes some time, and I explain it. I'll be glad to include, okay, this problem, but also there is another problem that I can include also, and I have only about 7 minutes, and forgive me, I have to go for this medical emergency, and I really appreciate, okay, your cooperation. I'm sorry to wake you up early in the morning, but probably, okay. So the second question of the week, I am going to, so the first question that related to the peak hour factor, how to calculate the peak hour factor, and the use of the peak hour factor, the minimum and the maximum values of the peak hour factors, plus typicals. I need you to know the maximum, I need you to know the minimum, I need you to know the typical values, the one I just indicated in my book, and it's available, okay, in the highway capacity manual. All this, okay, I'm not inventing anything or knowledge. It's just a matter of presenting the knowledge. The second question of the week, I need to talk about it. Coordinates. I said that coordinates are challenging problems during the exam. So if you have a horizontal circular curves like this one here, and I need you to solve, in addition to the problem that I will scan and send it to you. So assuming that you do have a horizontal circular curve, this is the back tangent, as all of you know, back tangent, and this is a forward tangent, okay, and this is the central angle delta. Let's assume that we have an angle of 40 degrees, okay, and if you extend the two tangents, they are going to intersect at the PI. Instead of giving you the coordinates like the problem I have here and here, he give you the coordinates here and here. So the PC and PT, the coordinates are given. So for example, this BC, it has a station of 14 plus 00, and the northern for this, okay, point is 2000, for example, 475 feet, and the eastern, okay, is 3000, okay, 570 feet, and I will scan this, send it to you. So, and the coordinates for the end of the curve, or the point of tangency. The northern is given to be 2,650, and the eastern, okay, it is 4,380, okay, feet. And the angle is given to be, okay, this angle, as you know, this is also delta, which is 40 degrees. And the question, there are many questions, okay, could be asked about this type of problems. As you look to the solution of this problem here, there are many steps, and not necessarily that he's asking for the coordinates of the power line crossing the curve at this point. He can ask you any other intermediate steps, okay, or intermediate step. So for example, if we have a station along this curve, is called POC, point on curve. Let's assume that you have a station, whatever the station is. Okay, let's assume I select a station or not. Station 16, okay, 16, station 16 plus 50. This is 12. Make it 15 plus 50. 15 plus 50. Okay. Okay. Somewhere. It's called POC, point on curve, and is asking what are the coordinates of this point, what are the northern and the eastern of this point. It is a good problem. Try to work it and we can discuss it. Okay, the third type of problem that you might see on the exam, or these are questions that maybe I received it from some of you, or maybe, okay, I thought about it, or we need to be ready. I don't know what will be on the exam. I'm just following the NCAAS series of topics, or the exam specifications as we call it. So the third type of problem, okay, related to the super elevation. And I discussed this and we solve a lot of problems about super elevation. You might see a problem. Okay, assuming that you have a 2-lane facility, center line, 12-foot lane, 12-foot lane. I have this problem already typed and I will be glad to send it to you. Okay, so we have 2-lane facility and it does have shoulders, and the shoulders that I selected, okay, to be, okay, 2 feet. And some of these problems are problems already I work on it in actual, okay, in my practice. Okay, so 2-foot shoulder. The cross slope here is 1.5%. As you know, the cross slope between 1.5 and 2 is acceptable per AASHTO, and the cross slope for this one here is 5% for the shoulder, or the shoulders. Okay, so the speed on this facility is given to be 40 miles per hour mph. This is, and the Emax, the maximum super elevation is 6%. As you know, the super elevation, the Emax per AASHTO in chapter 3, we have 4%, 6%, 8%, 10%, and the maximum super is 12%. And we already covered this, and the maximum super elevation. Okay, and they have equation over there, and we can calculate all these things. So as all of you know, that the super elevation is a process of adjusting the road to accommodate the centripetal force that will be trying to push the cars outside. So we are tilting the road, okay, or banking the road, as we call it, banking. So this is a PC and this is a PT. Okay, and this is the tangent, the back tangent, and this is a forward tangent, as all of you know. So this is the crown, as we call it, a crown. This is somewhere here. If you look here along the tangent, if this is section AA, this is the section AA. We start to lift the road or tilt the road, okay, before we enter the curve. And we do have what is known as a super elevation transition and a super elevation runoff, which is something called L sub R and L sub T. And we need to know how to get these values. There are equations and there are tables. I prefer the tables. The tables are very powerful, and there are 4 tables in the geometric design of highways and the street, chapter 3. You will find these things and they'll talk about it. To get the L sub T plus L sub R, and we need to know the difference between them. And the L sub R, in fact, is going to be, generally speaking, we have 2/3 along the tangent, 2/3 of L sub R, and 1/3 along the curve until we reach the full super here. The moment here we reach E max, which is a full super. They call it full super. And the question is, this road is going to be start to tilt. This a curve to the right, by the way. This is R and this is R. So he can ask you many questions. One question could be, after the road reach full super, everything will be in 6% like this. And this is the high side, by the way. This is the high side, and this is the low side. The road is this a curve to the right. Okay, so this will be the high side because we need to prevent the cars from being pushed out by the centripetal force, as all of you know. So he can ask you, as I told you, many questions. And when I received the question, I said, yes, there are many questions could be asked. He can ask you how that looks like the road at the PC, or maybe, okay, 50 feet. Let's take 50 feet, 50 feet, okay, from the PC. He can give you a cross section like this. He said that the road will be like this, okay? And this is the center line. The center line, by the way, is going to be the axis of rotation. Axis of rotation. Who said that? Also the geometric design of highways and the street. They said that when we have a 2-lane conventional highway or 2 lanes like this, so the axis of rotation, there are different axis of rotation. It depends on the configuration of the facility. But for a 2-lane conventional highway, the axis of rotation always the center line. And I can explain even this more if you understand what is known as a super elevation diagram. Super elevation, and I have 2 of them in my books. Super elevation diagram. And I was lucky way back when I joined Caltrans, I drew these super elevation diagrams by hand, by the way. And I'm teaching them for a long time. So nowadays, yes, we are using computers and the computer programs like Casey or Civil 3D or En-ROAD can draw the super elevation diagram, but you have to modify it to get, okay, the correct drafting information. But if you draw it once, okay, so this is where we have Emax. And the Emax will occur here at the end of the 1/3 of the L sub R. We need to get L sub R and L sub T, and they will explain this. So he tell you how it looks like the cross section, and he can give you probably the difference between the high side and the low side of the road. How much the difference in feet or in inches or something like that. This is again, go ahead and do it. I need you to tell me what will be the difference in elevation between the high point, and this is a high and this is a low, 50 feet away from the PC. How much is this distance here? in inches. Let's make it in inches. And this is another, if you understand the super elevation diagram, oh, it will be a piece of cake. It's a time consuming game. Yes. If this is a time consuming, the coordinates, yes. Okay. The first question that I talked about it, which is the peak hour factor. This is a conceptual question, and there are many conceptual questions. I have about few minutes left. I will arrive 5 minutes late to the place. It's only 5 minutes away from me. So forgive me. I have to leave right now to take care of this medical, and we'll keep working. Email me if you have any question. I wish the best to all of you, and sorry that the first day today is short, but I will do my best. Okay. Hopefully this will not happen again, but so let us do our best. Okay, thank you very much for coming, and enjoy your the rest of your day. Keep studying, keep asking questions, and I will do all my best to help you, and I hope the best to all of you. And please accept my apology, and bye bye everybody. Thank you very much.